All right, in this first video, we're going to be reviewing how to graph quadratics that happen to be in vertex form. You can see the vertex form identified for you right there. The key thing is to be able to discern when you are in vertex form and when you're not, because if the whole thing is about how to use a shortcut, we need to make sure we can, in fact, use the shortcut. The shortcut is easy. Can you use it or can you not? If you're not in vertex form, you might look something like this one, where you have this structure here, where the main difference, what you'll notice, is that the x is only listed one time in vertex form, usually in the structure with the parentheses in the middle, but not always. So here we have our structure where we only have the x value listed one time. We only have one x, we only have one x. When you are not in vertex form, you're going to have this extra x term here in the middle. That is what keeps you from being in vertex form. Okay, so I think they're pretty easy to spot. The only one that is sometimes a little bit hidden for people might be like this last one. Okay, this last one sort of doesn't appear like it's in vertex form because it does not have that parenthesis structure, but it also doesn't have an extra x. And so this one would also be in standard or in vertex form, and we'll do that in just a second. All right, so when you are in vertex form, I have provided you the structure here. All of this could be solved using a table of values, but the whole point here is we're looking for shortcuts. So when you have this structure in the middle with this x minus h, the quantity squared, then what we know through a trial and error is that the graph will just slide over to positive h. So we're going to actually move to positive h, meaning the vertex is going to go from 0, 0 to h, comma, and the k just moves things up. So we're just going to slide over to h and up to k, and then we know where our graph is located. The a value is my scale change. So that simply means if you have no a value, then there is no scale change. If you have a scale change, then we're just going to change the spacing between the points. The typical spacing when we graph is that we go up 1, we go up 3, we go up 5, we go up 7, etc. And so if we have a scale change, we just multiply by those numbers. So if it's a equals 2, for example, we're going to go to 2, 6, 10. Between those two things, that's all there is. Okay, so let's get some graph paper on here and let's graph these problems. Please eventually pause and try these on your own and come back and check. I'm going to do them quick. The vertex is going to be located at -2. One little shortcut you can do is just like drop this straight down and change its sign, and then bring this down and don't change its sign. And there is your vertex at -2, -4. There is no scale change, and so we are simply going to locate -2, -4, and no scale change. So we're going to go up 1, we're going to go up 3, we're going to map it on both sides, and then we're going to make a nice smooth curve connecting what we have done. And that is all there is. That is 100% all you have to do to graph a quadratic. So in this one, it is in vertex form. We're going to shift to +3. Again, just bring that straight down. Bring this straight down. So we're at vertex of 3, 2. And the scale change has not changed. So we're going to go to 3 and 2. And then we're going to go up 1 and up 3. At least 5 points of accuracy. Hard to get another couple of points on most graphs, so 5 is sufficient. All right, at this point, I would encourage you to pause the video and do the remaining, looks like 4 problems on your own, and then check back, see how you did. All right, on this one, the vertex, bring the 1 down, change its sign. Bring this down, do not change it. There's your vertex, 1, -3. That's all there is to it. I'm sorry it's not harder to justify the confusion some of you seem to be having, but I promise you this is all there is. 1, -3. Now, my vertex is located. My scale change of 1, 3, 5 is going to get doubled, and that's going to give me 2 and then 6. and then 10, but we're not going to go that far. So up 2, 1, 2, 3, 4, 5, 6 more. Match it, and you're done. Judging on the test, some of you are just going the wrong direction, even if you identify the right point. So I think that's just a careless issue and not double checking. All right, well, let's do the vertex first. Bring that down, change it to -4. Bring down the 1. We do have a scale change on this one. And notice that it's a negative. So we haven't talked about that yet. The negative is going to flip the graph over. So we're going to go down from the vertex instead of up. All right, -4, 1. I'm going to make sure, since I'm going down, that I move my axis to give me room. 1, 2, 3, 4, up 1. Double check. And now I'm going to go down 2, 2, 3, 4, 5, 6. I'm down 6. And that's it. I am done. This graph is finished. All right. And then I put on a few on here that look a little bit different, simply because I don't want you to get alarmed when they're different. We just need to recognize that, number one, we are in vertex form. And this just means that we have only moved to the left or to the right. We're just moving sideways. And there is no number on the outside moving us up or down, so we're still at 0. So this one shouldn't scare us. In theory, it should be easier, but again, sometimes when they look a little different, we think that they're hard. So we just slide over 4, and then we've got our 1 and our 3. And that's it. We don't have the up or down, so we don't go up or down. And then to contrast that with the next one, we don't have a left or right. So notice in this case, we have no structure, right? We don't have this part right here because it's just a 0 in there. And so why would you write x minus 0? You wouldn't. You would do x minus 0 and get x, and then it's only x being squared. So all of this means is our vertex is at 0, 3. We only go up 3. And so we are going to go up 3, and it's going down. So I'm going to give myself enough room below. 1, 2, 3. And we're stretching it by 2. 2, 1, 2, 3, 4, 5, 6. And that is it. All right. If you miss problems on the test on vertex form, I highly encourage you to practice as many as you can until it is second nature. You don't even think about it. You just graph them.